Alrighty, let's get things going. So again, people are still kind of joining in, but we'll get things started. Thanks again, everyone, for joining today. Um, we, as mentioned in our last webinar series that some of you joined, we are kind of starting to put together some technical webinar series. Try to help the industry grow together, different topics, different things. So it's something that IACE is pretty big on, and it's always good to just get the industry together and kind of learn from some experts. So we'll go on from there. Ahmedi, if you can.
Thank you, Ali. Good morning, everyone. I am
And
AHMEDI B.
before you get started, let me just mention that we have as we discussed, we have the technical webinar series. Um, And today we have our two speakers. Louis still joining in the field, having a little bit of technical difficulties, but we have AHMEDI B, project manager at Accurate, and Louis Patino, Sioux Field Operations Manager. And they will be giving a presentation on subsurface utility. So with that, I'll hand it off to Ahmedi. Thanks again, Ahmedi, for the time spent putting this together, and it's really a good overall look at Sioux. So we're looking forward to it.
Thank you. Thank you so much, Ali. Thank you for the opportunity. Good morning, everyone. I'm AHMEDI B. I'm a project manager at Accurate Growth, having 13 years of working experience in transportation engineering. And I'm also a project manager for Subsurface Utility Department in Accurate Group. So with me, I should have Louis Patino. He's our field operation manager. He has like 25 years of experience working in field for subsurface utility, all his basically for his career. He should be joining, but like Ali said, he has some technical issues going on to join this webinar, but he should be able to get in. So the webinar is basically for the subsurface utility engineering. We call it as SUE, S-U-E. So before we start the subsurface utility engineering information or the investigation about it, we just want to know, why do we need to know what is underground? So what is the reason of knowing the information underground? So usually all the utilities are, whatever utilities we get, we underestimate the underground utilities. They're poorly documented. They're inaccurately mapped. The atlases or the maps, what we get, those have like inaccurate information. Or some private utilities, those are like unknown utilities in field. Those unknown utilities creates like a lot of potential hazard. Those becomes a conflict, and it creates a costly and potential hazard to the industry during construction phase. So during excavation and construction activities, we may encounter some unexpected utilities that will damage the utility, that risks the safety of people, the public workers out there, and it will result in delays of project, and it will increase the construction cost because of the delays during the project. So basically the key message is, before you do anything above ground, you want to know what is underground to avoid all these issues, all these unexpected utility conflicts. So what happens? What happens when the contractor is unaware of any utilities out there, existing utilities underground? So it is all kind of disaster is what you're gonna see. Because what I say underground utilities would be like the water mains, gas mains, any kind of conduits, any ducts, manholes. So if you happen to strike any of these utilities, it's gonna lead into a big disaster. If you happen to strike a gas main, the leak of gas, if you happen to kill the water main there, or the fire hydrant, all kind of disaster, which is gonna be not safe. It's a safety risk for the people if you don't know the information and just happen to strike it without with unexpected encounter to it. So in order to avoid this disaster, all the thing what engineering and the construction does is they follow certain procedures, certain steps to protect the utilities during construction, during design phase. So first step, what usually do, what is the law for Illinois, is to call Julie before you dig. Any planning or any excavation or any digging, which happens in Illinois, it is by an Illinois law that you call in Julie. So it's a utility locating information for the excavators, basically. So you call them, it's an online ticket thing, you call them, and they give you the information about the utilities. So the main purpose is, again, to prevent the utility strikes, for the safety of the workers out there, for the safety of the public out there, and it also reduces the damage of the existing utilities, which we are unaware of during digging process. So how Julie works, what happens? Like, how do you use the Julie, basically? So excavators, contractors, or utility owners or property owners, what they do is they submit an online ticket to Julie requesting they give certain information about your project, about the project limits, and that information, Julie collects that information and send it to the utility owners. Utility owners, they send the locators to go locate the utilities within that project limits. And what they do is they mark the utility using colors. There are like a certain color codes for each utility. They use like a blue for water, yellow for gas. So whatever utility is out there in that project limits, the locators goes and then they locate it. That's how the excavator will know, like, okay, these are the limits, these are the locations of the utilities, and he will excavate around those utilities and he will try to prevent the utilities which is out there. So if Julie is what we use, then what is the reason why the Julie is not enough? If you have Julie, it's a free system. If you can just reach out to them, then why is it not enough, right? So basically, we do Julie call when we are in field. So basically, it is for the excavators, for the excavation safety. It is not for the engineering design. So when you are out in the field during construction, is that as like couple days or 14 days or 7 days prior to the digging is when you call them. So it will not give you any information about the conflict. So you cannot do any utility conflict. Say if you are doing some kind of relocations of water main or something, and if you find some other utilities based on the Julie map, you won't be able to do anything in field at that time. It's already too late in the game for you. So those are the drawbacks. Like the locations will be approximate because the utility owners give some information for them to go locate it. Those are records, those are research maps and atlases is what they use. They don't have any depth information. They will give you the horizontal information, and the utility conflicts, of course, will not be able to study because you're in the field right there. If anything happens, it is what it is, right? So information what we get from Julie, that's like a complex for the complex design, it's not enough information. The markings are temporary, so if something happens, the marking gets disappeared. And also any private or unknown utilities are not part of maps or atlases, so they won't be able to locate those private utilities. So Julie is an essential first step, of course, in the excavation safety. But when the project becomes more complex, you will need more information. You will need more investigation to have a proper utility information out there underground. That's when the evolution of subsurface utility starts. That's the reason of having little better investigation process. So SU is evolved because the traditional utility record, because of that one call system, that's not sufficient for the modern design of infrastructure projects. And also the growing need to better manage the risks and uncertainties associated with these underground utilities. Those can be managed with the help of this subsurface utility engineering process. So what exactly is subsurface utility engineering, right? So it's an engineering practice. It is a branch of engineering which investigates about the utilities by means of record research, by means of locating the utilities, by mapping the utilities, and by excavation, the non-destructive excavation methods. These are the combination of investigation. That's a process which is used to investigate the utilities which is underground. So what subsurface utility engineering do? So this is all it does. Now exactly what we need is it saves the time, it saves the money, and most important that it saves the lives, right? So that's what you need to know. It's not like an easy thing. It is actually important stuff to know in your engineering phase, in your design phase, to overcome the construction issues. So now how SU works, like what do you do in the subsurface utility engineering process? So it follows a systematic process which progressively improves the accuracy of utility information. So you do a step-by-step process, you do investigation in steps, which is called like a quality level investigation. The quality level starts with D to A, D being the lowest utility investigation and A being the highest level of investigation. And the SU, what we do, it is not just a typical process, it's actually ASCE standard. We follow ASCE 38-22 standards. It's a standard guidelines for investigating the utilities by ASCE process. So like I said, all the SU, what we do is done in quality levels. It's the step-by-step process with a lower level to the higher level. So we call it as D, C, B, A. So what comes in quality level D to A is record research. So when you do any record research, or if you talk to a village engineer, if you talk to any engineers or utility owners, you have a verbal discussions with them, or they give you record research, that's called a quality level D information. And quality level C is when you see the above ground visual features, like you see manholes, you see valve walls, whatever information you see above ground, that is considered as a quality level C information. With the help of your quality level D record research, you connect them, you correlate them. That's the quality level C information. And in quality level B, that's a little progressive way. There you actually use a SU equipment, which is called a geophysical method equipment. You use those equipments to locate the horizontal positioning of the utility. So it gives you some information about the utility. And quality level EA, that's the highest level where you get the vertical depth of the information. So horizontal will be kind of accurate in B, and then you get the vertical levels. I'm going to explain you in further slides about how exactly the process is carried and what is the process done to get all this quality level and when this quality levels are done. So this is how the quality level D looks. You get the atlases, you get the maps, you have some record research, like you call the OUC department. They give you some information from utility owners. That's the information you use. That's a verbal data collected information or some papers, historical documents, or as-built plans. So it's a low reliability because you get one piece of information, not necessarily those are as-bills, or not necessarily, those are up-to-date information. They're pretty up-to-date, but not necessarily to the date when you want them, right? So you call it as a low reliability unless you go and check in the fields. So the process for this quality level D is, like I said, you call OUC, you call Julie, they let the utility owners know. Utility owner sends their locators to get the information. That's the process in construction. Now in the design phase, what you do, you collect the information. So you send the information to the OUC record. They give you the research depending on your project limits. You give them the project information, you give them design stage of the project, they give you the limits of the utilities, what they have within our project limits. For the city of Chicago, it's a different process, a little different process. The utility owners pays to the department and then they go from there. For quality level C, basically what the survey we do, it's a topographic survey basically, and you do a visual interpretation, like usual location of your above ground features. It's an evidence you see there, like a transformers out there, like a manholes out there. So you survey them and you correlate that information again with the QLD information you have. So this is not used for the design phase, like a thorough design phase for the complex infrastructure thing, but it helps in mapping and studying the purpose of the design. So these are the equipments, like any kind of surveying equipment is what you use, like manholes, power poles, hydrants, and all those get shots. Those gets processed, and you get basically a topographic map, and you use your records to get this level. That's called quality level C. Next is your quality level B. This is where you use your SU equipments, right? It is a utility designations. It's a most common method you use to get the positioning of the utilities. The equipments are called geophysical equipments, and you actually mark the utilities. Those utilities, what are marked, they get surveyed at every couple, like at 20 to 50 feet at every shot, those get surveyed. Again, all the information, because it's a step-by-step process, all the information you correlate with each other. So the more data you get, you use your back data from your quality level D, from your quality level C, and then correlate each of them to go forward to get the investigation updated for your utility. So this was a slide for Louis. I don't know he is on, so I'll continue with it. This is about the equipment, what we use for quality level B. So it's electromagnetic, sonic. So these are like a transmission where he connects from the receiving end to the connecting end, and that's the device he's using. So that's not Louis, but that's a picture from someone who is using the device. So they come in like a different signal clamps, 2-inch, 4-inch, 5-inch. The different methods of what they use are direct connection method, ring clamp, induction method, just the induction. So electromagnetic equipment and transformer or receiver, transmitter and receiver is used for the designations of quality level B investigations. This is the same thing. Some other equipments, what they use. These are for the EM carrying and EM signals. The application is like an empty conduits, or for drains and for sewer lines is what they use. And this is the ground penetrating radar. It detects some traditionally non-locatable subsurface features. So metallic and non-metallic pipes, PVC, asbestos, cement, concrete, and some sewer systems. So it detects those. The utilities, if they are broken or damaged, the tracer wires, those kind of utilities can be investigated. The information can be obtained from this process. Then comes the quality level A. This is the highest level of accuracy to obtain the utility information. It's a non-destructive process where we expose the utility by digging the utility. If you see that there is a vac truck, you use that truck and then you actually excavate. So 3x3 or like a small hole gets created. You excavate the ground until you expose the utility, and then you get the information. So basically you get to see the utility, you measure the utility information, you get all the vertical depth information and the location horizontally with respect to some of your reference line. So that's like the highest level where you expose them and you get the information that will help you understand the utility conflict analysis. So here is the picture of the same thing, quality level A. On the right side, you see a large excavation. That's like a big old hole. Backhoe method is being used. The other side is the vacuum excavation. You use a vac truck. You expose the utility using a little pipe-like structure there, and you expose the utility. They get some information from their quality level B for the horizontal positioning of it. That's where they start digging it, and they get to expose the utility. They dig up until they see it, and then at the end, because they put it at everywhere they want to go dig it, so they will restore the area back to how it is. So it's just basically considered as a non-destructive method. So you don't do anything to the utility, and you do a careful process. So this is the coring method. You do a pavement. This is like a pavement coring and the excavation on your right side. This is also the quality level A excavation equipments, what we use in SU engineering. So the step-by-step process. So now you know what is subsurface utility engineering. You know what is the process for it. What are the quality levels? What each quality level means, like a D level, C level, B, and A. How do you do this process? Like what tells you you need to go all the way until highest quality level? So you start with quality level D and go to E. So the process would be, first, the designer, he will have his project limits. He will do a research to get the utility records, like the process what I explained before. So he will do a research to get the utility records. Once he gets the utility record, he correlates with his plans to see what he's gonna do. And then if he finds that utility, what he's looking for, all the utilities, what he received from the owners, if they are not within the project limit, done. He don't have to worry about it. The investigation can stop. That's the investigation for quality level D. So say if you are doing any kind of relocation of water main within your project limits, you have certain location selected, that's where you want to put your water main. Then you start your investigation, see if there are any other utilities out in that area. If you don't find anything in that area where you're trying to relocate your utility, perfect. You are good to go. You can proceed with your design. But if you have your existing utilities in the area where you are designing your water main, for example, and there is a possibility that it's going to conflict with your proposed design. So at that time, what the designer does, they reaches out to the clients so they can send the surveyors to get more information, above ground information of that, and the potential conflict information. So surveyor goes, they do the survey above ground, they get all the utility features above ground, like manholes, valve boxes, everything gets surveyed, it gets processed, and we get a topographic survey. We correlate that with the research information we have, and then we will see the utility design versus what is out there to see if there is any conflict. Again, if we don't find any conflict now with this information, we are good, perfect. We have to just, there is no longer conflict. We can end our investigation. That's the investigation, which is called quality level C. Next is say, now with this investigation of quality level C, now you are very close to seeing that there is a very high possibility of having a conflict with your proposed design. Assume like you have some other utilities out there, gas mains or something, and then assume that your water main has no other choice than going where you're trying to design it. But if you find some other utilities in the same area, you want to investigate more about that utilities. So what designer does, it lets clients know, and the clients will send the supervisors. Now it's time for Louis to go. So he's gonna go designate the utilities using the QLB method, so which will give him the exact horizontal positioning of that utility out there. All the information gets traced and that gets surveyed. We get the file in the CAD format. We put the file on our design file just to check the horizontal positioning of the utility conflicts. If there is no conflict now, if we think everything is good, there is a clearance. So usually utilities need some kind of clearances between the two facilities. If those clearance criteria is met, we are good. We don't need to worry about moving forward with any more investigation. That's the investigation called quality level B. But now we are like, okay, this is exactly at the place you are designing water main, what you're designing, for example, right? If it is right where the existing facility is out there and you have no other choice to have it where it is, then your last bet would be to see if it is in vertical, if it's a vertical conflict. Horizontally, it can be conflict, but they can be at a different level. So you want to see what the vertical conflict is. That's when you tell your client again to get some test holes. That's what quality level means. The excavation, what you do, that's called test holes. So now the surveyor goes, get their rack trucks, they will get the information about the utility by actually digging it, by actually exposing the utilities. And you get all the information, top of the utility information, size of the utility and everything. That's when you can do the conflict analysis and conclude whether that's in a perfect conflict or not, and then you will decide what you want to do. If you have to change your design, you will change your design in your engineering phase itself. But if you happen to not be able to do anything to your design, at least you will let the utility owners, or you let them know, the clients, that the existing utility will have to be relocated. So that was the entire process of finding the utilities from the lower to the higher level. Now your utility conflict will be resolved by either changing your design or by actually relocating the existing utility, which is out there. Whatever is the cheaper option or whatever is the feasible option is what we go with, right? So this slide tells you, so the information what I gave you is not enough information about the subsurface utility, of course. So this is the standard guidelines. This is ASCE 3822. That's what you use. So if you want to know more about this investigation process, you can go to this guidelines. And the one for the new utilities is 7522. So the goal of SUE is, of course, now accidental damaging of any underground utilities can be reduced, and it can be done in the early stage itself. You can avoid all potential hazard, safety of the public, safety of the workers out there, and of course, like delays during construction, that can be reduced. So if you know about the utilities beforehand during the design phase itself, you can actually change your design, and you don't have to wait until the construction happens, and that's when you know about the utility, where you can do nothing but wait until something happens, until you change your design or until you relocate the facility. So potential redesigning option is already taken care in the design phase if you have the subsurface utility engineering done. It will reduce your construction cost, any damage to the existing utilities out there. And if the contractor claims for, for the delay resulting for the unexpected encounters, so that can be reduced. Any unnecessary relocation. So say now this is where your utility is designed, but at least if you're doing your design phase, you can move wherever you want it. So unnecessary relocation of existing utilities can also be avoided. So the best thing would be like the safety gets enhanced during this process, which is the main requirement of everything in the engineering phase. So ASCE, this SUE for municipalities, like I said, ASCE 38-22. That's the standard book, which will give you the entire information about who, what, when, where, and why the use of SUE on the projects are needed. So these are the typical deliverables. We, as an Accurate, do a lot of SUE projects. We have done hundreds of them, a lot for District 1, District 8, for counties, for Wisconsin DOTs. So these are the typical deliverables we do in all kind of phase 1, phase 2. Design phases when we do, and we give them PDFs. We do all the CAD files. We give them KNZ files, all the utility matrices. We give them raw, raw survey data, all manhole details. Once they get the test hole information, we give them all test hole information with the photos, what they get in field. So all this information to the contractor will be helpful for him to understand what's out there, and the designer also. So additional advantage of having SUE information, not necessarily the whole information would be correct for the 3D, but we can generate a 3D model based on the horizontal information from QLB. So since it gives you the actual location of the horizontal, it is very accurate for the horizontal information. So it gives you, we can actually generate the 3D model in both OpenRoads and in GeoPack that can be used to develop your cross sections. We cannot guarantee, of course, the vertical distances, but the horizontal location can be found. And if needed, when we call for test holes for quality level A investigation, that information can be added to your model to exactly locate the utilities in your cross section. So you don't have to manually input your utilities if you have your subsurface utility investigation done in your design phase. So I love this part of SUE to use in design, because your cross sections are the most trouble in your plans. So some research was done in Purdue University study that federal studies found that every dollar you spend for subsurface utility investigation saves you $4.62 during construction. This is one of the case study happened during our engineering phase. This is the project on I-80 west of River Road. There was a box culvert which was asked for reconstruction for more capacity, like to increase the capacity of the existing culvert out there. So based on the upstream and downstream inward elevation, the location of that box culvert was in direct conflict with the BP lines out there. And since we knew that these are in conflicts, we investigated. We did the SU investigation for this and did the test holes. We happened to see that they are direct conflict with this box culvert, and the SU investigation kind of confirmed that conflict. But the worst part was that the pipeline companies had acquired their easement before I-80 was built. So any cost to the relocation of these BP lines, if we happen to find it during the construction process, any cost for the relocation would have been 100% reimbursement to the IDOT. So what we planned was we keep the existing culvert out there as is, just rehab that culvert and build a culvert west of that to give additional storage for more capacity. So with this method, with this design process, with this investigation and everything, we happen to save $30 million in 18 to 24 months, which would happen, like, if you have to relocate or something, it saved time, it saved money. So the total saving, that was the goal, which was achieved in one of this project. This is not the only project. There are several other projects we have done where we had to realign the roadway. The utilities were right there. We had to go look for the test hole, get the information about the utility. And again, the cost of the second project was also with the pipelines out there. The relocation of pipelines are kind of expensive, of course, right? So we happened to change the alignment of the roadway. So those kind of thing is what's done during the investigation process to help save money, help save time, and moreover, any damage to the utility can cause the lives of people. So in order to save all those things is why we do subsurface utility engineering. Thank you so much. That was all. If any questions, I should be able to answer, hopefully.
Yeah, thank you, Ahmedi. I just, want to thank you again. Sorry, everyone, for the technical difficulties. We're hoping Louis could expand a little bit on some of the equipment that's used. So we finished a little early. For some reason, WebEx doesn't want to let Louis in as a presenter, so that's kind of what we're dealing with in the background. But again, thank you everybody for joining. Ahmedi, thank you for time spent putting this together, and I think it's a great presentation, kind of going through the processes, the equipment, the different things we consider when doing SU. It's obviously a essential part of projects, especially complex projects. So of course, Ahmedi is available. She's willing to take questions now or later, so feel free to throw questions in. Looks like we have the first one, Ahmedi, from David Wilcox. Can you please share any limitations to QLB, especially vertical locations, and if different types of QLB equipment are more accurate vertically?
That was Louis' question, actually, but I can answer part of the question, and we will share this question with Louis so he can give us information about what equipment will be better to use for the quality level B. But like I said, quality level B investigation is more for horizontal positioning. It is less likely used for vertical information. The conflict study is for horizontal information only. Does that answer your question?
Okay. There aren't any other questions. Does IDOT have a cell library built out for all the various duct bank configurations for electric and telecoms, such as 3W, 2H?
No. So we use a generic, because we use this 3D model, so we have a generic cells we use. We create some cells. There are some cells, but it doesn't give you the entire size of it. But if the size is critical to your design process, then you create the cell. There is an option to create your own cell for the size you need.
Okay, I'm not seeing any more questions. I'll ask a, oh, we got another one in. Can you describe an instance when you would use a large excavation QLA?
So yes, with this whack truck, it can the Louis would have explained it better. Like there is a 20 psi or 30 psi. That's what they use to do to excavate the ground out there. But it can do so much. The back truck excavation is limited to certain